Good morning. I want to welcome you to the November 6th, 2025 edition of Coffee Break. I'm Matt Bilsma. I'm a sales engineer here at Long, and I'm going to be presenting today on the heat pump sizing, air-to-air heat package heat pumps sizing, particularly looking at the heating capacity for comfort heating and cooling applications. First of all, I want to give some credits here. This presentation is inspired by a presentation that was given at the Daikin sales meeting by Jeff Seawald at the Daikin National Sales Meeting. Today's objectives, we're going to think through heat pump sizing for packaged air-to-air heat pump applications. It's important to note that some of these applications will cross over to DOAS and ERV applications, but we are particularly looking at comfort heating and cooling applications where we have higher mixed air temperatures. We'll cover low ambient operation and defrost considerations, as well as talk about some different heat sources for supplemental cooling or heating in these applications. Of important note is in retrofit applications, we should consider existing structural and electrical constraints and what we are dealing with for existing equipment, whether it's existing packaged DX and gas heating as well. Moving on, I just want to highlight primarily what I'm going to be referencing here when we're talking about heating operations for heat pump and auxiliary heat is the Daikin Rebel and Rebel Applied line, available from 3 to 68 tons, and with different supplemental heating applications. Steam is available in the Rebel Applied, but not typically applied for most applications. So primarily, we're going to be concerned with gas, electric, and hot water heat. Just to address some of the challenges here, we are talking about heat pumps, and in our climate, low ambient operation is of particular concern, especially as our heating capacity available decreases in lower ambient temperatures while the heating load increases in our building. We also need to consider the emissions and our grid. Where is our electric power being generated? And what is whether it's gas, coal, solar, and so that we can be concerned about our overall carbon footprint, as well as the other impacts on the other building systems here, whether it's controls, structural engineering, electrical. So in this example, I'm going to be using some weather data from Chicago, Illinois, in this particular example. It's important to note that the overall curve is very similar to the Denver area. However, in the January and February timeframe, there's more bin hours, heating hours for Chicago than there are here in Denver, as well as in the cooling season, July and August, their cooling hours are higher. But in general, the curve is very similar. So in this application, you can see that when we're concerned about low ambient temperatures of 15 degrees and below, that's about 4% or less of our operating hours. Furthermore, if we concentrate on our heating temperatures of 60 degrees and below, we're going to kind of focus in on that. So in this graph, you can see the temperature, the outdoor ambient temperature is on our lower axis. On the right axis is the number of hours in a year. And then on the left, we've got our heating load and our capacity. So as kind of a linear function, our heating load increases as we get colder. And if we were to overlay size an air-to-air heat pump for 100% of our maximum heating load, you can see that as we work to the right on this graph, as we get into moderate heating temperatures, our heating capacity for that heat pump is oversized for our heating load, as you'd expect. As we then consider what might we do to more closely match the number of hours and size of our equipment for optimal use in our heating mode, we might be able to downsize that packaged heat pump. We're talking about equipment that's available in nominal capacities, from that 3 to 68 ton range. And so if we do that, there's some transition point here that, and in this application, we're talking about, around between 20 and 25 degrees. So anything to the left of that transition point, we are now going to be reliant on supplemental heating. And at that transition point, you can see here that our cumulative hours, we're less than 10% or so of those hours that are below that transition point of 25 degrees. And two, so right, what we're trying to do here is maximize the first cost of our equipment as far as, lowering the budget of that equipment, and then maximizing the operation where we're reliant more on supplemental heating, whether that's electric, gas, hot water. Important to note here, in this transition temperature, we also need to be concerned with defrost operation. This is showing kind of a linear heating operation, which is not really the case. Somewhere in this operation between 20 to 40 degrees typically, we are going to possibly see frosting on that indoor coil, the coil inside of the unit. And as that frosting occurs, our unit's going to go into defrost operation if the climatic conditions are such that we've got moisture in the air and our dew point on that coil is below freezing. So this linear operation then would start to, curve down, and this supplemental heat would creep up and supplement the heating capacity during the defrost operation. So it's important to note that, and you need to be concerned with that defrost operation. If you're doing an overall energy study for any particular project, you will want to consider that, and based on whatever your relative humidity or well temperatures are. Furthermore, just kind of one way of looking at this for our overall cumulative hours here, as we get to the left of this curve for our ambient air temperature, as you could probably guess, our coefficient of performance on the heating side is going to drop off. And it's going to get to a point where that transition point, if you think about how our grid power is coming in, what does the overall COP need to be where more sense to transition over to whether it's gas, electric, hot water for our auxiliary heat? And we need to consider that as well, because our coefficient of performance is dropping off drastically as we get down below that 20 degrees temperature. Moving on to kind of just overlaying what our options are. So you can see here, this is looking more at now over on the left axis here, we're looking at carbon emissions and what is our overall impact of the heat pump as we transition over to supplemental or auxiliary heat. You can see that for less than 10% of the hours, when we're looking at an all-electric option for heat pump as well as an electric coil, in this particular case for Chicago has a grid that's still relatively dependent on fossil fuels for electric power generation. And so here, when you're looking at carbon emissions, in this particular case, the heat pump plus natural gas for auxiliary heat is actually a lower carbon emission when we get down below that 40 degrees, and especially when we're talking about that transition point of less than 10% of our cumulative hours of operating hours. So just in conclusion here, I want to just talk about how, some of the ways that we as we transition from thinking about the old way of doing things to now. When we're looking at RTU sizing, we used to look at cooling and heating as two independent functions. We sized the nominal capacity of a rooftop unit for, let's say, 25 tons because we had a calculated load of 20.1 tons or something like that at altitude. And so we're going to have a nominal 25-ton unit. And that might have been available with let's take a gas heat, for example, a low, medium, and high furnace option. And we would size those two independently. Now, with the heating operation moving to heat pump, we need to be concerned about, are we oversizing that 25-ton unit in this particular case to a 35-ton unit, or we're into a different casing size. We've drastically increased our price point for that. So the overall, as well as we've got more materials. And so our carbon footprint of the equipment alone has increased. And so when looking at this, we really need to consider what are we doing to the overall budget for the first cost, operational hours. We saw that in some cases we can have lower carbon emissions below that 25 degrees. And that'll change obviously with each project as we have different outside air concentrations in our unit. But it's important to note all of that, as well as looking at decarbonization goals. Do we need to, are there certain things that are off the block as far as equipment considerations? Do we have whether it's an energy code or a project objective to have no gas, no fossil fuels? So it takes hot water powered by a boiler and a gas heat and a furnace off of the table, and we're looking at all electric. So we need to consider all of that as well, and we might not have other options. Furthermore, as far as electric coils go, the operation, as this technology improves, with electric coils now through Daikin, for example, we can size a air-to-air heat pump unit and limit the electric coil capacity during heat pump operation such that we don't oversize the MCA, that we're not adding the total kW of that electric coil to the heat pump and the compressor energy and have a higher MCA and MOCP. So especially in retrofit situations, that can come into play. I guess all of this to say that we've got an iterative process now that to call your sales engineer, and whether it's a Teams meeting or an in-person meeting, to really think through and go through those heat pump applications such that you're aware of the cost differences, and maybe we're working with the sustainability consultant to see what our overall emissions are in our electric use, and where does it make sense, where is that transition point where it might make sense to consider a different auxiliary heating source. So in conclusion, a lot to pay attention to, a lot of things that we didn't have to consider before when it was just gas DX or DX electric equipment, and really pay attention to everything that we've got to offer. And as this technology continues to improve, we will make you aware of those improvements. All right, let's get to the part of the show here where we give away this week's prize. This week's prizes are Thanksgiving themed prizes. We've got a $100 gift card to help with that grocery bill for the big Thanksgiving day. We've got Poo-Pourri for that unsavory guest that needs a little help when they're 15 minutes away from you. And then for those who want to amp up the party, we've got a Bluetooth karaoke machine. Thank you all for joining us. Next week, Devin Gash will be hosting Halton, talking about pollution control and kitchen ventilation. Thanks for joining. Have a great day.